NASA just sent shockwaves around the world with a revelation decades in the making. Deep within their secret labs, engineers have been building something beyond imagination, a creation that could reshape life on Earth and open the door to worlds we've only dreamed of. Scientists call it humanity's boldest leap yet, a machine so powerful it could change everything we know about space and time. And now it's finally ready to be revealed. NASA, from bold beginnings to the frontiers of discovery. Since its official establishment on October 1, 1958, NASA has ascended from a national experiment in aerospace to the world's leading center for space technology and exploration. At a time when the world was gripped by the race to conquer space, the newly formed agency combined vision, talent, and ambition to build spacecraft, train astronauts, and design instruments capable of reaching beyond Earth's skyline, delivering discoveries that would reshape science and society alike. In its earliest years, NASA inherited several aeronautical and rocketry programs from its predecessor, the National Advisory Committee for Aeronautics, and quickly set its sights on spaceflight. The agency's early milestones included the Mercury and Gemini programs, which tested the limits of human endurance and orbital flight. By 1961, NASA achieved a historic breakthrough, sending astronaut Alan Shepard into space, followed soon after by John Glenn, who became the first American to orbit Earth. These missions not only demonstrated U.S. capability during the Cold War's space race, but also laid the foundation for human exploration beyond Earth. The 1960s and 70s became the era of unprecedented achievement. The Apollo program culminated in the 1969 moon landing, when Neil Armstrong's first steps on the lunar surface symbolized both scientific triumph and human courage. Following that success, NASA turned its attention to long-term innovation, developing the Space Shuttle, launching planetary probes like Pioneer and Voyager, and establishing Earth-observing satellites that revolutionized meteorology and environmental science. Over time, NASA's ambitions extended beyond human spaceflight. The agency's robotic missions, from the Mars rover's Spirit, Opportunity, and Curiosity to deep space observatories like Hubble and James Webb, expanded humanity's reach into the cosmos. Meanwhile, research aboard the International Space Station, continuously occupied since 2000, has deepened understanding of biology, materials, and medicine in microgravity. Astronauts aboard the ISS have captured over 5.3 million images of Earth, contributing crucial data for tracking deforestation, urban growth, and climate change. Yet NASA's influence is not confined to space. Many of its innovations have found everyday use on Earth, from water filtration systems and memory foam to infrared thermometers and lightweight materials used in sports and medicine. Through partnerships with private companies and global agencies, NASA has built a collaborative ecosystem that fosters innovation, education, and public engagement. Its research continues to inspire new generations to dream bigger, explore deeper, and reimagine what humanity can achieve both on Earth and beyond. Get ready to discover what astonishing new build NASA is currently working on, the next giant leap in space technology that will change everything. Polar radiant energy in the Far Infrared experiment. Since its dual launches in May and June 2024, NASA's Pre-Fire mission has been quietly orbiting Earth, conducting one of the most detailed climate studies ever undertaken from space. Each of its two CubeSats, each no larger than a shoebox, travels in a near-polar orbit, making systematic measurements of the far infrared radiation escaping from Earth's surface into the cold vacuum of space. These twin spacecraft represent a new era of compact, high-impact science, where smaller, cost-efficient satellites are unlocking massive gaps in our understanding of the planet's climate engine. Until Pre-Fire, the far infrared portion of the spectrum, specifically wavelengths longer than 15 micrometers, had been one of the least observed yet most critical components of Earth's energy budget. This radiation accounts for roughly 60% of the heat that leaves the Arctic and Antarctic regions. Because no previous satellite mission had measured it comprehensively, scientists were forced to rely on indirect models and assumptions. PRIFIRE, equipped with highly sensitive thermal infrared spectrometers built by NASA's Jet Propulsion Laboratory and the University of Wisconsin-Madison, is the first to capture this data directly. Each of the two satellites crosses over the poles several times a day, but at slightly different times. One passes during the early morning, while the other follows a few hours later. This staggered timing allows scientists to compare how far infrared radiation changes throughout the day and across the seasons. By collecting data from different angles and times, PRIFIRE provides a continuous picture of how clouds, snow, sea ice, and water vapor influence Earth's cooling process, a process that affects everything from global weather systems to sea level rise. The mission officially entered full science operations in mid-2024 and, thanks to its success, was extended through 2026. Researchers are now expanding its reach beyond the polar regions to gather global data that can improve climate and weather simulations worldwide. The mission's findings will help refine predictions for permafrost melt, Arctic ice decline, and polar cloud formation, key factors in understanding how warming in the far north influences the rest of the planet. But PRIFIRE's impact isn't limited to scientific circles. Its data will feed directly into improved weather forecasting models, helping governments and communities prepare for extreme weather and long-term changes. By precisely quantifying how much heat escapes from the poles, NASA is giving humanity better tools to anticipate climate shifts, manage agriculture, and protect coastal populations from rising seas. PRIFIRE stands as proof that even the smallest spacecraft can make a monumental difference in understanding Earth's fragile balance. The chill of the poles may hold answers to climate change, but NASA's next small satellite is turning its gaze toward the heat of distant suns. Pandora SmallSat. The Pandora SmallSat mission is one of NASA's most intriguing and quietly revolutionary ventures in development. Selected in 2021 under NASA's Astrophysics Pioneers program, Pandora is scheduled for launch in fall 2025, marking a new chapter in cost-effective exoplanet research. The mission's spacecraft, roughly the size of a household washing machine, will carry a 44-meter telescope into sun-synchronous low Earth orbit, where it will dedicate itself to the precise study of at least 20 known exoplanets, worlds orbiting distant stars beyond our solar system. Each target will be observed around 10 times, with each session lasting about 24 hours, creating a rich archive of data on alien atmospheres. The scientific challenge Pandora addresses is one of the most subtle in modern astronomy, separating the fingerprints of a planet's atmosphere from the noisy, ever-changing surface of its parent star. When a planet crosses or transits in front of its star, some of the starlight filters through the planet's atmosphere before reaching us. That light carries delicate spectral clues about gases such as water vapor, methane, or carbon dioxide, clues that can hint at the world's temperature, chemistry, and potential habitability. However, stars themselves are imperfect light sources. They have dark sunspots, bright faculae, and turbulent magnetic regions that can distort or imitate planetary signals. This is where Pandora's innovation shines. Unlike previous single-wavelength instruments, Pandora will perform simultaneous visible and near-infrared observations using the same telescope. Invisible light, stellar spots, and surface activity are easier to detect, while the near-infrared range reveals the molecular features of a planet's atmosphere. By studying both together, scientists can disentangle how much of the light variation comes from the star and how much truly comes from the planet. The result: clearer, more reliable measurements of what these distant worlds are made of and how similar or alien they might be to Earth. Technologically, Pandora exemplifies NASA's growing emphasis on small-sat missions, smaller, faster, and cheaper satellites capable of performing focused scientific tasks. Its 0.45-meter all-aluminum cast-grain telescope and streamlined operations make it a model for doing big science on small budgets. For the general public, the benefits may extend well beyond space. Pandora's insights will refine how we interpret light from distant planets, helping prepare for future flagships like the Habitable Worlds Observatory. Its innovations in sensor precision, thermal stability, and data processing could influence industries from environmental monitoring to optical communications. And most profoundly, Pandora pushes us closer to answering one of humanity's oldest questions: how many other worlds could sustain life? Hidden in the light of faraway stars, whispers of alien worlds are waiting, and Pandora might just be the first to hear them. Veritas. The Veritas mission, short for Venus Emissivity, Radio Science, INSAR, Topography, and Spectroscopy, represents one of NASA's most ambitious attempts yet to decode the mysteries of our solar system's most enigmatic planet. Planned by NASA's Jet Propulsion Laboratory and managed in partnership with the German Aerospace Center and the Italian Space Agency, Veritas is currently slated for launch no earlier than 2031. Once it reaches Venus, the spacecraft will enter a near-polar orbit and begin a comprehensive high-resolution survey of the planet's surface, topography, and internal structure, offering an unprecedented look beneath its dense cloud-covered atmosphere. At its heart, Veritas seeks to answer one of planetary science's most profound questions. How did Venus and Earth, two planets nearly identical in size, composition, and distance from the Sun, evolve in such dramatically different ways? Why did Earth develop oceans, weather, and life, while Venus became a runaway greenhouse world with surface temperatures above 460 degrees and pressures strong enough to crush most spacecraft within hours? To explore these mysteries, Veritas will deploy two powerful instruments. The Venus Interferometric Synthetic Aperture Radar will map the surface in 3 dimensions, detecting changes in elevation, crustal movement, and possible volcanic or tectonic activity. Meanwhile, the Venus Emissivity Mapper will measure thermal emissions through narrow atmospheric windows, allowing scientists to infer surface composition and detect signatures of active volcanism or even remnants of past water. What sets Veritas apart is its imaging precision. The mission will deliver radar maps with a horizontal resolution of up to 30 meters and vertical accuracy of about 5 meters, a dramatic improvement over previous missions like Magellan in the 1990s. After a several-month interplanetary cruise, the spacecraft will use aerobraking, dipping repeatedly into Venus's upper atmosphere to gradually settle into a low, circular orbit about 250 kilometers above the surface. Over the course of its 3-year primary mission, it will collect vast amounts of data, creating detailed topographic and compositional maps of nearly the entire planet. The implications stretch far beyond Venus itself. Understanding whether Venus is still geologically active or once had oceans will refine models of planetary climate evolution, shedding light on the long-term stability of atmospheres, including Earth's. For the public, this kind of research may eventually inform better climate projections, natural hazard modeling, and even Earth-observing radar systems, which often draw directly from spaceborne technology. Beneath Venus's toxic skies lies a story of catastrophe, one that could reveal what nearly happened to Earth itself. Dragonfly. The Dragonfly mission stands among NASA's most imaginative and technically daring explorations ever conceived. Selected in June 2019 under NASA's New Frontiers program, Dragonfly is planned to launch in July 2028 and arrive at Titan, Saturn's largest moon, in 2034. Unlike traditional landers or rovers, Dragonfly is a dual quadcopter rotorcraft, essentially a nuclear-powered drone designed to fly through Titan's thick, nitrogen-rich atmosphere and touch down at multiple sites across its mysterious surface. Titan is one of the most Earth-like worlds in the solar system, but with a surreal twist. Located 1.4 billion kilometers from the Sun, its orange skies, methane rains, and hydrocarbon dunes make it a frozen analog of early Earth. The surface temperature averages 137 hours, and beneath the haze lies a landscape of liquid methane lakes, icy plains, and organic sand dunes. Dragonfly's design takes full advantage of Titan's dense atmosphere and low gravity, which make flight easier than on Earth. Its 8 carbon fiber rotors will enable it to fly tens of kilometers at a time, hopping between regions to conduct direct sampling and environmental analysis. Once on Titan, Dragonfly will embark on a primary mission lasting about 2.7 to 3.3 Earth years, investigating how far chemistry may have advanced toward the conditions necessary for life. Using onboard instruments like a mass spectrometer, seismometer, meteorology sensors, and cameras, it will analyze organic-rich surface material, search for signs of complex chemical reactions, and measure atmospheric and subsurface properties. The data will reveal how organic molecules interact with liquid hydrocarbons and icy minerals, offering insights into what chemistry might look like on a world far colder and darker than Earth. One of Dragonfly's most compelling goals is to study prebiotic chemistry, the same kind of chemistry that likely preceded life on our own planet billions of years ago. Titan's environment offers a natural laboratory to test how far non-biological chemistry can evolve under alien conditions. The mission could help answer whether Titan has, or once had, the ingredients and energy sources necessary to begin life's processes, and what that implies for habitability elsewhere in the universe. Beyond pure science, Dragonfly's impact reaches the general public and technology sectors alike. Its innovations, from autonomous navigation in extreme cold to advanced sampling mechanisms, could shape future planetary exploration and even inspire technologies for drones, robotics, and climate monitoring on Earth. Each flight across Titan's surface will not only expand the frontiers of science, but also push the limits of human engineering. Picture a flying laboratory skimming over alien dunes, and then imagine what happens if it finds the chemistry of life frozen in time. Nemo. The next Mars orbiter is one of NASA's most strategically significant yet understated proposed missions, a project designed to revitalize and expand the orbital infrastructure around Mars for the coming decades of exploration. More than just another satellite, Nemo would serve as the next-generation communications, imaging, and data relay platform, supporting both current and future robotic and eventually human missions to the Red Planet. Still in the concept and study phase, Nemo's origins trace back to early NASA planning efforts in the mid-2010s. Initial projections imagined a launch window around 2022, but that timeline shifted as attention turned toward the Perseverance rover, Mars Sample Return Program, and Artemis lunar objectives. Despite the delay, Nemo remains a high-priority concept. It's intended to ensure that as aging orbiters like the Mars Reconnaissance Orbiter and 2001 Mars Odyssey near the end of their service lives, Mars does not lose its essential communications backbone. Technically, Nemo is envisioned as a solar electric spacecraft, offering both efficient thrust and maneuverability for long-duration operations. Its planned 20 km class solar array would power a high-bandwidth optical communication system, dramatically increasing the data rate between Mars and Earth. This means that rovers, landers, and future sample return missions could transmit gigabytes of scientific data daily, enabling faster analysis and mission updates. In addition to communication capabilities, Nemo would carry advanced imaging systems for surface mapping, landing site scouting, and environmental monitoring, providing detail far beyond the current generation of orbiters. A proposed mission profile includes a 10-month low-thrust transfer from Earth, followed by approximately 15 months of orbit capture to establish a stable 320 km circular orbit around Mars. From there, Nemo would serve as both an operational hub and a scientific asset, relaying data, monitoring surface weather, and even tracking atmospheric changes over time. From a scientific and logistical standpoint, Nemo's development underscores a critical truth. No surface mission succeeds without orbital support. Its communication relays would ensure uninterrupted contact with landers, its imaging would guide precision landings, and its systems could even coordinate multi-mission operations, an essential feature as Mars exploration becomes more complex and interconnected. For the public, Nemo might not carry the same drama as a rover making first contact with Martian soil, but its impact would be just as vital. The technologies it develops, from laser communications to high-efficiency propulsion, would likely spill over into Earth-based telecommunications and satellite systems, advancing how we handle data across space and planet alike. In many ways, Nemo represents the silent yet indispensable architecture behind the next great wave of Martian discovery, the invisible bridge connecting our expanding human presence on Earth to a growing robotic one on Mars. As future explorers prepare to set foot on Mars, Nemo may become their lifeline, the silent link between two worlds. Exploration Upper Stage EUS is the advanced upper stage in development for Space Launch System Block 1B and Block 2 rockets, and it marks a major leap in NASA's push for deep space missions. One of the core differences between EUS and the earlier in-space stage, that is, the Interim Cryogenic Propulsion Stage, or ICPS, is power and flexibility. The EUS is powered by 4 RL-10C3 engines burning liquid hydrogen and liquid oxygen compared with the single RL-10 engine of the ICPS. Its design allows the SLS to send significantly heavier payloads toward the Moon, Mars, or other destinations in deep space. For example, the SLS Block 1B with EUS is projected to increase payload mass for lunar missions from about 27 metric tons to roughly 38 metric tons in the crew version. Development of the EUS has been underway for several years. A preliminary design review was completed in 2017. More recently, in early 2024, the stage entered its qualification phase. Teams at the Boeing Michoud Assembly Facility in New Orleans have been preparing structural test articles, welding confidence articles, and verifying tools and assembly processes. From a general public perspective, the EUS may sound very technical, but its impact could be far-reaching. By boosting the lift and energy of the SLS rocket, it opens up possibilities for larger scientific payloads, more ambitious habitats, and quicker travel to farther destinations, meaning we may see next-generation space telescopes, lunar bases, or missions to Mars and beyond become more practical. Also, the manufacturing innovations, for example, large-scale welding of cryogenic tanks, advanced avionics and rocket stage automation carry over into industry, creating jobs, advancing materials science, and inspiring new technologies that have or will impact everyday sectors like manufacturing and aerospace. Every great leap into the unknown begins with a spark of power, and NASA is about to unleash one that could carry us beyond imagination. TSIS-2, the Total and Spectral Solar Irradiance Sensor 2 mission from NASA, is set to continue one of the longest-running records in Earth science. How much solar energy reaches our planet? TSIS-2 is the successor to the earlier TSIS-1 instrument, which was launched in December 2017 and contributed to a continuous solar irradiance record stretching back to the 1970s. Unlike TSIS-1, which flew on board the International Space Station, TSIS-2 will ride on a separate free-flying spacecraft, giving it more flexibility and stability in its measurements. The mission involves 2 major instruments, the Total Irradiance Monitor and the Spectral Irradiance Monitor. TIM measures the total amount of sunlight falling at the top of Earth's atmosphere, what we call total solar irradiance, or TSI. SIM measures how that solar energy is distributed across wavelengths, from ultraviolet through visible to near-infrared solar spectral irradiance, or SSI. TSIS-2 is currently in formulation planning and is scheduled for launch in about 2025. Why does this matter for everyday life? The sun is Earth's primary source of energy, driving weather, ocean currents, seasons, plant growth, and climate overall. Small changes in solar output can ripple through the atmosphere and oceans, influencing temperature, winds, and the very balance of energy in Earth's system. By tracking both the total and spectral solar energy with precision, TSIS-2 helps climate scientists refine models of how Earth's climate is changing and how sensitive the planet is to variations in solar input. For the general public, that means better informed forecasts of long-term trends, improved understanding of extreme weather risk tied to solar variability, and more accurate context for climate policy and planning. Also, because the sun's energy influences renewable energy potential, crops, ecosystems, and even human health, knowing how solar energy changes contributes indirectly to our everyday lives. The answers to Earth's future might not lie in the stars at all, but in the sunlight touching our planet this very second. As NASA builds the impossible piece by piece, one can't help but wonder, when these machines finally awaken across the solar system, will humanity be ready for what they uncover? Share your thoughts in the comments below.